Hello, I am Cameron Dolan. Like Ashton, I was mentoring under Michelle in Anchorage. Um, so my two projects were analyzing box truck data and doing some microgrid modeling for the Alaska Native Tribal Health Consortium. So the purpose of my first project was to research the feasibility of implementing electric garbage trucks into the municipality of Anchorage's waste system. By analyzing the telemetry data that we got from a Peterbilt electric box truck. The second, the purpose of my second project was to assist Michelle and a small group of researchers in microgrid modeling for the Alaska Native Health Consortium. So the goal of the box truck analysis was to determine the feasibility of implementing these garbage trucks into the waste system and determining the feasibility of implementing wind energy in the microgrid modeling. The bigger picture for the truck analysis was that diesel garbage trucks are some of the least fuel efficient utility vehicles out there. They burn on average a gallon of diesel for every 3 miles, which is both very costly and detrimental to the environment. So we hope to use this research to show that integrating electric garbage trucks is both environmentally and economically friendly to the MOA. On my second project, a big concern with using any large renewable energy source is finding a way to use any excess produced energy that might come from it. So through our research model, we're hoping to find a cost-effective way of storing or using this excess energy that would be produced by integrating wind energy into rural microgrids. So the research methods I use for the box truck analysis, this project's been going on for a while before I joined. So there's a lot of previous attempts at analyzing the data from my mentor, Michelle, and other past researchers and interns. Sometimes we would try to find some correlations between different data categories to see if there's any relation. Temperature is a big factor when it comes to using electric vehicles up here. So we use a lot of data, a lot of hourly data from NOAA, the weather service. And we used a lot of visualizing because it was a lot of data. We had roughly from 2020 to 2023. We had a lot of data to go through, so visualizing that was really important. There's also a lot of, there's some light linear regression use, trying to find out the capacity of the battery because we were not given that. So yeah, the project, we used Python, specifically Jupyter Notebook to program this stuff. We used a lot of pandas because pandas is really good at data manipulation and NumPy. So yeah, the microgrid modeling, this one's still kind of in its infancy. We just kind of started that. So there hasn't been a lot of methods taken into this yet, but the main program that we're using is a software called Homer Pro. This program is used to simulate microgrids and also optimize the microgrids. So you would create a synthetic microgrid based off data that you would get from the community, and you would use that to make a schematic of their grid. And then from there, you can add on stuff that you'd want to add. So say if you have a diesel run community, you can create that schematic, and then if you wanted to see if they could add solar power or wind energy, you could add that in, and then Homer will optimize that to figure out if it's feasible. Homer is a proprietary software, so there's a lot of black box stuff going on there, but they do have some of their equations out on their website. I found that really helpful to familiarize myself with the program by looking at and sometimes running through the equations themselves. So that was actually really helpful. So here are some graphs that we got for the box truck. This is specifically a graph that shows the kilowatt hours per mile over temperature. We saw that kilowatt, the energy consumption, that's what kilowatt hours per miles is. The energy consumption usually went up as it got colder. We found that if you drove the box truck 5,200 miles per year, it would use approximately around 10,000 or 11,000 kilowatt hours. Adding that at a cost of 11 cents per kilowatt hour, that would cost around 11.92 to charge, and it would have emissions around 5,420 kilograms per CO2 equivalent. These numbers compared to at the bottom, we have a analysis of a fuel truck. We used 7 miles per gallon, which is honestly kind of generous considering the average that you can find online. This came out at around $2,900 for fuel, and it would emit approximately 7,570 kilograms for CO2 equivalent. So we did find that the use of the box truck was mostly very environmentally friendly and more cost effective than using a fuel truck. This second graph is pretty similar to the first one. And this first one, we used a coloring of miles driven. So the higher the miles are driven, the more red it would be, lower it would be blue. On this one, we used the average heater setting data. So whenever the driver would turn on the heat, it would send that data, however high it was, to telemetry data. So we saw that as the temperatures dropped, the heater settings usually went up, which is to be expected. On to the other project, the microgrid modeling. This is a typical screen that you would see in Homer. This is specifically the electrical load profile of the community. There's a bunch of other stuff. As you can see on the left, there's a schematic diagram which shows you all of the components and loads that are connected to the grid. As you can see, we have a diesel generator and a wind turbine connected to this. This is specifically modeling the Marshall community grid. Most of its inputs from Marshall. We do have some synthetic right now just to play around with. We still are waiting on some more organic data, specifically with the wind speeds. So right now we're using synthetic wind speeds to kind of play around with it. And this is a typical results screen. So once you have your schematic ready and you're ready to see the results, you would calculate, and this is usually what it gives you. The top would be the sensitivity cases. This is a case where you would change it. As you can see, I have it set to do different wind speeds to see how much the wind turbine would generate. When you click on these individual little cells at the top in the sensitivity cases, it will show you the optimization results. And in the optimization results, you can see that it provides you many different results compared based on what you would want to add. So the first optimization would just be a diesel generator and a thermal control and a boiler. But as you go down, it could add batteries and a converter or a wind turbine, diesel, and batteries. So it gives you a lot of options to look through to see what would be the best way to model or, build your community grid off of. So yeah. I also took, me and Michelle took a little trip to Galena to hook up a vehicle tracker to a truck for another project. So it's interesting to see. We stopped by so Galena has a pilot solar array going up to see if solar would be a viable solution for them. So it was really cool to go out and see that. It was really beneficial to learning how microgrids work to further my work in the microgrid modeling. And yeah, as you can see, there's Amanda Bird, our storyteller up there. She was the one that took the drone shots, and Michelle took some of the pictures of me. Lessons learned. For the box truck data, the data was, as you could say, not great. A lot of the data points were missing in some of the categories. Some of it wasn't really explained properly, so there's a lot of talk between the data providers and us on figuring out what some of these columns meant. And yeah, it was really hard to work with. There were some correlations that we could have gone further with if we had more better data, or just more of it. Some of it was just we didn't have enough data to really take it any further. So yeah, if there was one thing I could have done differently, I would, and it's probably a pitfall many of us programmers fall into, is not commenting our Python programs. So sometimes it would be like, I would just be going through and I'm like, wait, where am I supposed to be on this? So yeah, I also would rather reformat it a little better so that it would flow a little better, be a little less spaghetti. If anything, I learned, Michelle said this a lot to both me and Ashton, is to not get too hung up on any challenges or walls you might face in your work. It's always, I figured that she told this to me and it really made sense, is that it's just helpful to take a step back from the problem and clear your mind, because when you have a clear mind, you work better and you can come up with better results. So yeah, the conclusion, I was able to successfully provide results for the box truck to provide to the MOA. So that was pretty nice. I was happy with that. Yeah, I'm happy in that I completed the work that I set out to do, this internship, and I'm excited to continue this project, continue my current project into the school year through the student employment. So I'm excited for that. Thing I enjoyed the least was dealing with bad data. And the thing I enjoyed the most was producing results from that data. It's just like, you're doing it and you're just like, oh, this sucks. And then you get to the end, you're like, oh, it really wasn't that bad. So yeah. And that's my project, or that's my presentation. Any questions?
Thanks, Cam. We have time for one question.
Yeah, that's fine. I know we're on a time crunch.
Oh no, you're so good. Great presentation. Do we have any questions online? Okay. Well, if you do have any questions, please feel free to contact Cam. Great work, and it was super exciting to see your presentation. Next up, we have Chris.